Hopefully everyone can see my slides. Great. So thank you for that introduction. So what we are going to talk about today is, how to build and integrate AI features into applications. So what we're covering in this webinar is really the full AI workflow that includes, application integration, some of the tools that are available for each stage from the major cloud vendors. I'd like to give you guys a perspective of what's out there so that you can, start using them. And then we will take two specific examples where we will do a full workflow using various tools available from Amazon Web Services. And we will go through two different examples that represent very common use cases in the business community. And they will be, one is an example of churn, where we're trying to understand how, whether or not customers are likely to leave a bank or whether they're likely to stay. And then the second is a sentiment analysis example where we will take Twitter feeds and then try to assess the positive or negative sentiment of the user based on the content of the Twitter feed. So first thing is, what is the full AI workflow? So what we have here is an example that is, fairly representative of what generally is considered to be a full AI workflow. Some people, have slightly different stages, but most, if you look at this topic online, you'll find that most of them have roughly these stages. And so we'll go through these in turn. So first thing is you have a business problem of some kind or a problem that you'd like to solve in your application or something you'd like to improve, and you identify what that is. Then you find data that is relevant to that problem, and that could be historical examples or instrumented information that you've gotten from your application and things like that. Using those exam data, you develop a model, and so you'll try to figure out what algorithms work and try to get one or two of them to train. You'll train these algorithms, and then you will test your models to see how well they're behaving. And then once you find an algorithm that or a model that you like, you will basically deploy that. And this is a very key stage because this is the stage where a lot of exercises and that focus exclusively on the training basically stop, is where you have a high quality model, and then the training task is generally considered successful. But in order to actually get real use out of what you've trained, you have to deploy it somewhere. And then you have to connect it to your application that has the problem. And then you have to monitor the result and make sure that you've solved the application problem. And frequently in real life, you have to repeat this cycle several times. So much like in development, we constantly repeat and optimize and improve our applications, this cycle is really no different. You do it once, it'll work, probably not as well as you'd like, then you'll do it again and it'll work better. And so the key here is that you have this flow and then you repeat this flow over time as much as you need to get what you want. So then this brings us to, why do we care about the full workflow and not just a subset of it, like the training part? First of all, in order to get value out of AI and actually improve your applications, you clearly have to connect them to the models that you create. And in order to understand whether or not the AI is truly benefiting the application, it requires that you deploy the models, connect it to the app, study the behavior of the app, and then likely improve it. And then through this cycle is how you show return on investment, or making show that the time and effort you put into doing the AI is actually benefiting your end application. This is, however, fairly challenging because you do have to deploy the AI somewhere, and you have to basically connect these stages together in order to actually get value out of it. And so that's what we are going to talk about today, is how to do that in the cloud. So the first thing is that there are a lot of technologies out there already in the cloud to help anyone who's trying to do this. And in order to illustrate the sheer, volume of the things that are available, what this slide has is each of these little pictures is a logo of a single product offered by one of three companies, Google, Amazon, or Microsoft, in the cloud just for AI. So you can see that just even across these three companies, there's an enormous number of tools available. And that is not counting, what's available by IBM, SAP, anything in open source. So if you add those, there's yet more. So the key here is you don't really need to find, there's no lack of tools. It's really, less about, finding a new tool. It's about figuring out which tools to use and how to use them together. That really is the key to getting, something deployed into your and integrated into your application. So at a base level, in order to build and use an AI workflow in the cloud, you kind of have to do the following steps. And what we will do is describe these steps to you in the abstract, and then we will do specific variants of these steps using specific tools. So we're going to start this slide from the bottom up. And the first thing is you have to run your AI somewhere, and you have to, have compute, you have to have a place to put your data. You have to be able to connect your data to your compute, do this in a way that's safe and is not hackable, and then keep an eye on how it's doing. So you need logs and things like that. And so the first thing is you have to pick your infrastructure. An example of an infrastructure would be something like, Google Compute or Amazon, Elastic Cloud or things like that, where there's infrastructure services. Then you need to have some data. And then depending on what's going on with your data, you may need a labeling service to help you label the data, or you may need some data prep or visualization tools to help you see what you've got. And once you understand your data a bit better, then you will go through the modeling and the training cycle. And once you have your modeling and training cycle, then you can build new models, you can train them, tune them, you can use built-in algorithms available by some of these tools, or you can build your own, depending on what you're trying to do and how sophisticated you want to be at it. And then you have to deploy. And there are many ways to deploy, but one of the most common ways that we will focus on exclusively in this webinar is REST deployment. And so the basic idea here is that you deploy your model or your inference, the part of the model that does the prediction, as a service. And this follows the very common microservice pattern. And the service is running somewhere, in our case, somewhere in a cloud. And then it presents an API. And using that API, your application can make a request and get a prediction. So effectively, if you, for example, if it is a quick case of churn, then the application will provide a profile of a particular customer and the REST API or the REST service will come back with a prediction that says, yes, this customer is likely to churn, or no, this customer is not likely to churn. So if you get the basics of this kind of stack in place by connecting together whatever tools you'd like, then you have effectively the mechanism needed to run a full AI workflow in the cloud. So now this is a bit of an eye chart, so I would encourage you not to try to read everything in this. The key here is is to illustrate to you that there are lots of different services out there, as we showed in the graphic with all the little logos. And there are different services for each stage of the workflow. So for example, for data preparation, there are services for visualization, for performance monitoring, things like that. And what you have here are the different services available from the three major cloud vendors. What is highlighted in green is what is actually going to be used today in this webinar and what we are going to essentially demonstrate to you. So we are able to create a full end-to-end workflow using this subset of tools, out of the large, collection that Amazon offers. And this subset is enough to do the two use cases that we're talking about here. So the first thing we are going to demonstrate, and we'll show you how this works basically through a demonstration. So the first thing we're going to demonstrate is churn with binary classification. So before we, just a little bit about the use case. So this is an open source data set. It's from Kaggle. It's a variant of the data set that is found at this URL. So if you want the original raw data set, you can go directly to this URL and get it there. If you want the version that you modified, I'll provide you with a link later where you can get the modified version. The modifications that we made were basically to simply remove a few of the columns that were not necessarily relevant to the exercise and made it a little bit easier to run through the workflow. So that's where the data set is. And what this data set describes is profiles of customers at a bank. And as we go through the demo, we'll show you the data set itself so that you can see what it actually looks like. And what we're going to show you is the infrastructure that we'll be running on is Amazon EC2. We will be storing our data in S3. We are not going to show the data prep and visualization, but we will show you how we use Amazon SageMaker and QuickSight in order to basically model and train this. And then we will use Amazon SageMaker and its Lambda infrastructure and its API gateway infrastructure to deploy it. Then we will show you with Postman how you connect. And this will be representative of any application that you would like to connect with, because the API is exactly the same. So you can use any application in any language to do that. So just to kind of, because the flow can be a little bit involved, I'm just going to go through it as pictorially so that you'll be able to better appreciate what you're seeing in the demo. We'll start with the data set. We will make some changes to it using a Jupyter notebook because the data set needs to be changed in particular ways to make it suitable for for SageMaker. And then we will put the modified data set into S3, and then we will attach it to SageMaker and train a particular algorithm that will generate a model. Then we will create a SageMaker endpoint, which is effectively SageMaker's service infrastructure with this model. And then we will create a publicly accessible endpoint through the combination of a Lambda and an API gateway. Once you've done all of these steps, then what happens is that a URL, a publicly accessible over the internet URL, appears that to which you can make requests. And then we will use Postman, which is a very common API testing tool that you can get from the Postman website, and you can download it for free. And you can essentially test out your API using that tool. And then you can embed the same API into any application you like in any language. So now we'll just switch over very quickly to the demo. I'm just going to really quickly close my window and open up my demo. And full screen my demo and then start playing it. Okay, so what you're going to see here is we'll start by opening up the data set. So now I'm going to just show you the data set really quickly. This is effectively all of these columns are features, and this is the label that we want to predict, and it's called exited. So 1 means that this particular customer left the bank, and 0 means that they didn't. And then the other things are things like their credit score, their age, how long they've been at the bank, things like that. So the first thing we're going to do is we're going to change this data set into a format that is acceptable to Amazon's SageMaker. And we're going to do that using a Jupyter notebook. Now, there are 2 changes we need to make. First of all, SageMaker requires that the label column be the very first column in the data set. It also requires that the headers be removed. So this piece of code will switch the columns over so that the label shows up at the beginning. And then this piece of code below will simply remove the header. Okay, so what we'll do is remove all of those. And now what we have is a modified version, which we'll take a quick look at, and you'll see what the changes that we've made. So now you can see that it's essentially the same data set with 2 modifications. This is the exited column, and all the headers are gone. So the next thing we'll do is we'll bring this data into S3. Now we already have an accounts on Amazon and they're already set up. So if you don't have an Amazon account, the first thing you should do is to get one. And then through that, then you will be able to upload into S3. So we'll upload this from our laptop. Okay, and now we have it. And now we're going to go to SageMaker. And what we will do is start a training job using this, this particular data set. We'll give the training job a name. and we'll pick out an algorithm. In this case, we picked out XGBoost. So what you saw there is that there's a number of built-in algorithms in SageMaker. All of them are documented in the SageMaker manual. So you can read those documents and figure out what algorithm you'd like to try out with. So we are trying out XGBoost because it's particularly, powerful and useful for this kind of binary classification. What you have here is you get to, configure what type of Amazon instance you'd like to run your training on. What you have here are the hyperparameters for the XGBoost. Now, a couple of different things here. These hyperparameters are described in detail inside the Amazon manuals. Some of them are optional and some of them are required. So what we are going to do is we're going to essentially add this num rounds, which is a required parameter that we need to fill in that doesn't have a default. We're going to leave all the other defaults the way they are. And one change is to convert, make sure that the XGBoost uses logistic regression, right? So that because we want to do a classification exercise. So there you go. So we're going to go and pick from there and go with binary logistic. Okay, now we've configured the algorithm. And then we're going to specify the file that we previously loaded up and also say that the file is a text and CSV file. So you have to specify the type and the format so that it knows how to read it. And then we'll provide the path name of the file that we just uploaded into S3. And then you need to actually change the prefix because Amazon, a SageMaker wants the prefix in a very particular way. So keep an eye on this format because this is the format that you would need to use, even though it's the same file. And then you want to provide an output path. This can be mostly what you like, but this is where your models and other things will go. So you want to provide one. Okay, now we have our training job. You can see a little bit about our job there. So it's running right now. Okay, and now we can create a model. Now, in order to create an endpoint, you need to create a specific model artifact and then attach an endpoint to it. So what we're going to do now is create a model, give that a name. And these are the default inference code images that are provided by Amazon. So we're not going to change those. Okay, so now that we've created a model, now we are going to attach an endpoint, a SageMaker endpoint, as we talked about. So the SageMaker endpoint is where SageMaker will receive inference requests and make predictions. Okay. Now that we've created a SageMaker endpoint, our next step is to go ahead and try to make this externally visible as a REST service. In order to do that, we need to do two things. We have to create a Lambda, which is a serverless function that when it gets a request, will invoke this endpoint. And then we have to attach that Lambda to an externally visible API gateway. So we'll now go ahead and do those two things. And it's important to remember the name of your endpoint because we need to invoke it inside our Lambda. So a Lambda is basically a simple function that we will write right now, and we'll give that function a simple name. I'm going to write that in Python. So this execution role is basically part of the Amazon authentication that you will set up as appropriate for your organization. And then what you have here is we're going to replace this default Lambda with a simple Lambda. And all it does really is that it effectively creates a handler that says invoke the endpoint. And this is the endpoint that we have for our, from our SageMaker. And so whenever a request shows up, it's going to take the body of the request and shove it into the endpoint and then get back a response. And that's all that it does. You can see that the response will be 0 or 1. And that's the same name. That's exactly the name that you need to put in there. And we invoke that endpoint by that name. And that's, and that is the Lambda. This is the small serverless function that we've created now. Now we will go to the API gateway and we will create an API gateway for our service. And we will attach that API gateway to this Lambda so that anytime a request comes over, it will invoke the Lambda. So now within the API gateway, there are various methods like the post method, for example, and we're going to attach this to the post method so that whenever anybody calls post, then we know that this Lambda will get invoked. We'll go down and attach it to the post method. And this is our Lambda, the one we just created. Okay. And now what we will do is deploy this API. Now, just a quick note here on stages. Essentially, you can have multiple stages in your deployment if you're, like a full professionally run organization. And this will allow you to decide which stage you want to deploy it into. For example, you may have a test stage, a production stage, a staging area, and things like that. And you may wish to deploy it into any one of those or all of them. Okay, now, now you can see that now this is our URL. This is the publicly available URL to which any program that you write, as long as it makes a post to this URL, it'll be able to send a prediction request into your recently trained model. And back will come as part of the HTTP response will come the prediction, in this case, churn or not churn. So now that we've got that, now this is Postman. This is, as we said earlier, very powerful and generic API testing tool. What you do is you put your URL here, you put the body of your data here, and this is, if you notice, these are all the different fields in the customer profile. This was the credit score, this was the income, and these were the other fields in between. So now what we will do is we will put our URL here and we will send. And we've effectively sent this data body and the response has come 0, as in will not churn. You can change this data body, like say to 50, and then it's more likely to churn. So things like that. And so you can basically use this mechanism to interactively test your API as much as you like. You can also scale test and do other things. And then when you're ready to add it to your application, what you need to do is to identify these fields, put them into a data body just like this, invoke a post request, and later we'll show you how to do that. And then after that, interpret the body field in the response, and now you've integrated, essentially. So that was a quick demo of the churn use case. Now what we will do, and just for the folks online, we'll be taking questions at the end of the webinar. So, so please post your questions on the Q&A or, ask them on the chat or just ask them at the end, and we'll be definitely taking all the questions. So the next demo we'll do, which we will do a little bit quicker just because many of the steps are very similar, is sentiment analysis with text classification. So again, this is a data set you can find in open source. It's from Kaggle. The changes that we've made to this data set is we've shortened it fairly substantially just to make it an easier cycle to run, but the steps will work with exactly the larger data set. And then what we've also done is we've removed the levels of sentiment from 5 different levels to just 2. so that it's easier to tell between purely positive and purely negative sentiment. Again, we will show you how to run on Amazon EC2 and S3, do modeling and training, and then do the application linkage as well. Oh, and one additional major thing that we are going to show differently in this one is that text classification is an algorithm that is not natively available as a built-in in SageMaker. So you will need to provide your own. And what we did here is we took a scikit-learn algorithm, and we are going to package it up as a Docker container and then upload that Docker container into SageMaker. And now those are the steps that we will focus on, because the rest of the steps are practically identical to the ones we did earlier. So first thing is, let's take a quick look at the data set. And in this particular case, the data set is already got the label in the front. 4 means happy and 0 means sad. The rest of it is just a simple expression of text. And so all we need to do to make this data set suitable for SageMaker is to remove the headers. So we're not going to use a Jupyter notebook. We're just going to edit it directly and just delete the header row, the line that has the header. So we'll delete that real quick. Now we have a data set that's suitable for S3, for SageMaker, and we'll upload that data set into S3 exactly the way we did the last time. Okay, now that we have that, now the next thing we're going to do is to create our Docker container, and we're going to put in this particular scikit-learn algorithm for text classification. So this is a standard scikit-learn algorithm. You can get it from scikit-learn itself, and it's available in open source. And it's going to use a random forest classifier. Now we are going to use a script called build and push, and this is a slight variant of a script that is provided by SageMaker that you can configure in order to build your own Docker container. So if you want to use the script, go ahead and look in SageMaker and you will find a copy of the script. So we're going to create a build and push, and what this will do is it will create a Docker image, and it will push that Docker image into your SageMaker so that it will show up as an available image in your SageMaker account. So it'll package up the code, the necessary dependencies, and go ahead and now you can see that there's a name of a Docker image. Now, if we go to SageMaker, you'll find that there's a copy of that image, sitting in SageMaker. So the rest of the steps have been intentionally sped up in the video just to save us a bit of time, because the rest of the steps are basically the same steps. So I'll just really quickly narrate them, but they are the same as what we did before. We will create a training job. Okay. And here we are basically providing the container path because we provided a new container image. And then you decide the size of the instance that you want to run, and you provide your hyperparameters. Again, we provide the path name of the file where we put this stuff in S3. So you go back to your S3 management console, find the path name of what the file was, and then tell SageMaker what that was. Okay, and then make the same changes format-wise because it wants a very particular format, so you want that. And these are the same edits we made the last time. Now, there is a notion of a channel here, and what we are going to do is create a training channel and a validation channel. So these are basically two places where your program, your container program will run, but it can take different data sets. In our case, we're going to provide the same data set, but if you wanted to do different training and validation sets, this is where you would create them. And again, provide the output configuration as well, a place where your models and other artifacts will be kept. Okay. And you can see this has been sped up, but it's the same thing, which is we will create an endpoint. We will create a Lambda, basically a very similar Lambda to what we created before. All the same role settings. We will replace this with our Lambda. We will find the name of our Lambda and we will attach it to our API gateway under the post. Provide our name of our Lambda. We will go ahead and click deploy, pick a stage for it. And now we have our URL. We go over to Postman. We put our URL in there. And our text in this case is basically text because we only have one field and it comes back with happy or sad. So hopefully this gives you an idea of, how to do, various types of deployments in Amazon, various Amazon tools. And you saw how this various tools are connected together. So what we're going to do really quickly now is we're also going to show you a little bit of a tool that my team and I have been working on. And what it does is it basically takes the same tools that you are using and the same thing, everything is still running on Amazon. And what we've done is automate the linkage of the tools so that you don't need to link the tools together yourself. You can use the Navigator as a layer above to link the tools and manage the transition. We also help with the selections of algorithms and things like that. So what we will do is we'll show you the same two use cases, but through Navigator, and the same things will be happening. So we'll start with the bank churn demo. So what you see here is the Navigator user interface. And what we will do is we will create what is called an AI service. So we give our AI service a name. And then, the same, here also we want to bring our, data set into S3. So what we will do here is we will use the local and upload our data set, and it will be placed automatically in S3 under a bucket for your account. Then you can import the data set so that the SageMaker system can have access to it. And then now here you can see a quick glimpse of the data set, and it has the same fields. Now note in this case, you don't actually have to edit the data set in a Jupyter notebook because that will be done for you automatically. So the data set that you're seeing here is the raw one that we showed you initially. It has all the same fields. If you want to take a quick look at this data set, you can go to Explore Data. And it can show you some statistics about the data set and things like that to help you understand it a bit better. So you can see that it has extracted out all the different properties and shows the different schemas and the fields and things like that. And the raw data is here. Now we go back to creating our AI service. And the first thing that we will do is specify what we'd like to predict. So what is the label? Since the label is not in a fixed place, the system wants to know what the label is so that it can prepare the file suitably for SageMaker. So we selected exited, and now it's going to prepare the data and engineer the features. So this will do a variety of things like, split the data into train and test, check for columns that have unknown formats, anything that might make the data unsuitable for SageMaker in any way, and also create that separate train and test channels, which will be done for you through the dataset. So now this is actually creating an endpoint for you, the same endpoint that was created before. And you can create the endpoint before you create a model. So if you're a developer and you want to train with a stub, then now there's a stub there for you to train. To test with. But now we will go ahead and do training. Now, the training has been classified into automatic and semi-automatic. In semi-automatic, algorithms will be selected for you that match your data set, and hyperparameters will be provided that you can edit. And so you can pick all or any subset of these algorithms. If you do automatic training, it will do everything for you automatically in terms of selecting what algorithms are suitable for your data set, as well as populating all the configuration parameters. So depending on how much control you'd like to have, you can either select automatic or semi-automatic, and the right jobs will be launched on SageMaker appropriately for you. Okay, so what you're seeing here is the training, and it's launched 4 different SageMaker jobs for the same data set, and it's going to pick the best one and make a recommendation of what you should deploy. So it's deployed and recommended and deployed the best one. And deploy essentially means now that you will be able to use the endpoint with this model in it. So the end outcome is that there will be an endpoint with a URL, just like there was before. And anything you can do to engage with that endpoint is the same in either case. And what you see here is that there's also a small dashboard here, which is manual testing, where you can test the endpoint directly here without necessarily having to use a tool like Postman. And you can enter in various values, and you can get predictions based on different values in terms of what the algorithm predicts. You can also connect. These are code stubs that you can use to connect with various types of applications. So if you wanted to do just a generic command line test, you can use curl. This text is also exactly what you would need to provide inside a Postman. If you wanted to do Python, there's a code stub here of how you would do a Python import, and you can see that the code stub is very small. So if you just put this tiny little code stub into your program, you are automatically communicating with your running prediction service. So the act of connecting to a live prediction is actually very easy for any application program. So hopefully that gives you an idea of how a different way to sort of also accomplish the same thing. Sorry, I'm fiddling with my window here for a second. I'm going to pause sharing for just a second. Okay, got it. Yeah, I know, I got that. Yeah. Okay, I'm going to start. So I will show you also really quickly a second demo that is the same. Am I sharing my screen? No, not sharing. Okay. I'm sharing. Here we go. I'm sharing it again. Okay, so what I'm going to show you is a second demo for the sentiment analysis use case, and the steps are the same. So this one we'll do very quickly because the steps are the same. So in this case, my file has already been uploaded onto S3, so I'm not going to upload it again. And there it is. And I'm going to go over and say import. And you can see the data set here, and it's exactly the same one, except that the headers have not been removed. And we're not going to go ahead and do explore data because we already know how that works. And you can predict and say you want to predict sentiment from expression. Same steps as before. All the same splits of train and such. A mock endpoint has been created. Now you will see that automatic training will actually select a different algorithm here because this particular one is a text classification. So similarly as we did before, we have to do a different algorithm. This was one that we already loaded into SageMaker. So you have, it will automatically select the text classification. Then you can go ahead and deploy that the same way as before. And what you will see here is a dashboard appropriate for this. So where all you have to do is to enter in the expression, and you will get a 0 or a 1, depending upon what it thinks about the sentiment. Just enter in something else here. Happy, so you get a sentiment of happy. So those are our demos, and that showed you kind of how you do a full workflow using Amazon Sage tools. If you would like to try the Navigator layer and you are interested in a free account for it, please go to this URL, aiclub.world, and sign up for a free account. And then the AWS is built in. So to try out the free account, you don't need a separate AWS account. You can just go ahead. And there's also a bunch of examples. The data sets that we actually used in this, which are slightly derived versions of the Kaggle data sets, are also available there. So if you'd like to download those data sets directly for your use for any reason, you can feel free to go ahead and do that. So that's all that I had, and I'd be happy to take any questions at this point.
Thanks, Nisha. I think there's some questions in the Q&A section and also in the chat. So if you want to
Perfect.
Do that.
I'm just going to go through the Q&A questions. I'm going to read them each out and then answer them. Okay, first is, could we please provide links in chat? Yes, I will provide the links in chat in just a moment. The presentation link, Bill, are you planning to post it? If not, I can arrange to post it somewhere.
Yes, you can have the slide sent to me and I can share it to everybody.
Perfect. So that's the answer to that. So I will provide it to Bill and Bill will share it. Perfect. Okay, question from Patrick. In practice, do you try multiple models offline and then proceed with your preferred model? So in general, this is a good thing to do because usually different data sets, they respond differently to different models. So it's generally a good idea to try more than one. And being able to try them in parallel and then use a metric like accuracy or root mean squared error, depending on what you've got, it can be used to pick the best one. So then the next question is, I assume you need to provide AWS credentials to Pixida initially so that you'll be able to see all the configs and logging directly and things like that. Yes, so if you want to use your own AWS credentials, yes, a part of the setup is to provide your own AWS credentials, and then everything will run on your own account, and Pixida will just be used to link them together. That's correct. Next question is, when you test your model in SageMaker, do you get any metrics like precision, recall? Yes, so SageMaker provides a number of different metrics. The metrics depend on the algorithm that's being used. And the way it works is that there's an Amazon service called CloudWatch. When you run your SageMaker models, the metrics go to CloudWatch, and you can get them from CloudWatch. There are also links in SageMaker, which will link directly to CloudWatch that then you can use. That's the answer to that one. So let me go ahead and look at the chat now. Okay, let's find the questions in chat. I'm just gonna try to scroll up.
I think you can just look at the last one before previous the other one. I think you already answered.
Okay, terrific.
Yeah, just jump to the last one.
Okay, so let's see. So this, how can you select a different model in Pixida Navigator? So the way you select different models is there's two options. One is you can select among the semi-automatic. We're also adding the capability to bring in your own models as you wish. So there's two ways to do that. And then what is the equivalent of SageMaker in Azure? So Azure has a whole bunch of tools. I don't recall their names. I believe they fall under the umbrella of Azure ML. But essentially, the similar functions are available. What I can do really quickly is I can go scroll up to the sheet that had all the gigantic list of tools and see Azure under data prep, machine learning, serverless, auto ML. So Azure ML and Machine Learning Studio are the ones that provide that function in Azure. So if there are any other questions, I'd be happy to take those as well.
I think there are a few more in the Q&A.
Okay, so let's see. So there's one that says, where can we get the slide deck? I think we already addressed that. Let's see. Yes, there's a question about recordings. We addressed that. And I think the question is, will the recording be sent to the registered emails? I think that's a question for you, Bill.
Yes.
Okay. Let's see what else. There's some questions about the meetups. I think you've answered all of them if I look at it. And then, oh, there's more in the quick Q&A. I see them now.
Yeah, they're more in the Q&A.
Okay. Okay, so next question is, would you include links to all tools, scripts, data files, etc.? Yes, I will make sure that the scripts, everything is updated when I send you the slides. For everything that is
Okay.
in, there will be links. Okay. Will you share the recording session? We already answered that. Next one, using these tools, is it possible to train on premise and just upload the trained model? Yes, that is also possible. We haven't covered how to do that, but if you have questions offline, I'd be happy to, show you how to do that. But yes, you can bring in a trained model and just use the REST deployment part. Are you going to share the Python code? There are code snippets available that will be in both. I can attach the code snippets and provide links to the Python code. Yes, do that. Can you continue training a model after you deploy it initially? Absolutely. So one of the things that's very common is to retrain. And so you have to have the ability to retrain. And so in Navigator, for example, you can just select the AI service and say retrain. And then you can create a new model, as many as you like, and then push it to the live deployment endpoint. And SageMaker has mechanisms to do that as well. Okay, next question. Does the integration your team build seamlessly do the same with GCP and Azure? We are adding that support right now. We don't have it at the moment, but yes, and that is the order also in which we're adding it. Can you share the example AWS GCP services spreadsheet? Yes, I think we can include that in the slide deck that we provide. Thank you, great. I want to experiment with SageMaker. Do I need a very powerful computer? No, you don't need a very powerful computer. Everything will be running on the cloud. So your laptop is more than fine. That's what I use. Okay, I think I got them all.
Okay, great. Thanks a lot. We are a few minutes left. If anyone have any questions, you can ask now. Or we can end the meetings a little bit early today.
Actually, there's a couple more questions here. Bill, hold on.
Really?
If you retrain,
Okay.
you need a new endpoint? No, you can retrain and push the new model into the same endpoint. Okay. Then the next is, how would you update the trained model if more data is coming? What you would do is you would do a retrain. And in Navigator, for example, retrain can be done with new data. You can even do it with new features if you'd like, as long as you're training on the same labeled column. So yes, you can absolutely retrain with new data of any kind. And the way that it works is that the training occurs separately, and then you will do a deploy, which will seamlessly replace the model that is in your endpoint with a new model. Your endpoint URL stays the same, and so all of your programs that are accessing the URL will stay exactly the same. And that's basically it. So it's very straightforward and seamless. Are any deep learning algorithms available in SageMaker? I believe there are. I haven't used them personally, but yes, if you go to the SageMaker documentation, you'll get a list of all the algorithms that are there. Okay, so I think that was actually it. Then thank you very, very much, everyone. Oh, one more question. Okay. How do I version my models as we iterate? So the versioning is handled automatically. So, for example, you can actually go and look at all the models that have been saved. And then if in Navigator, we manage the versioning directly so that in your dashboard, you can see, all the different training experiments that you've run for a particular AI service, and you can see what order you ran them in, what parameters you used, as well as what results they got. You can do the same thing in SageMaker because the native function is in SageMaker, but it might take you a little bit more work to try to assemble them together, but they're all there. Everything is versioned. Next question. What are the advices you would give for a Java developer to get started, possibly the shortest possible path? Well, I mean, if you'd like to sign up for a Navigator account, it takes only a few minutes to get something going, and we can provide you with code script snippets. The steps that we use are the same, so you can, start there, and then as you get more sophisticated, you can try out lots of other tools as well. I think, Bill, I finally got them all. Or maybe not. Yikes. Okay. How would you evaluate the accuracy automatically chosen algorithm? So the accuracy is computed using the standard function. So what we do is we do an 80-20 test, validation and train split. We run the data set against the validation data, and we use, for algorithms that are classification, then we compute the predicted response against the label. If the algorithm is not classification, then we choose an alternate metric like root mean square error, and so Navigator will pick for you the right metric depending on the kind of thing you use. If you're using native Amazon SageMaker, it will provide a series of metrics for you as well. And then you can look at those metrics, and that metrics will depend on the algorithm, of course, because the metrics are always dependent upon the algorithm. Any other questions? I think we have about 1 minute left. Let's see. Okay, one more. Is there a maximum training duration or size limit of the data used to train? Yes. So Amazon has various size limits. And so what you need to do is to check sort of the nature of your account. And there are limits on some of the API gateways as well as sizes. Generally speaking, the default will do under a gigabyte, reasonably comfortably. Between 1 GB and 10 GB, there are various Amazon limits that you would want to be aware of. So typically about 5 GB, you should not have a problem. 1 GB, for sure, you should not have a problem. But then after that, you would need to really check your Amazon, values. The maximum training duration,